Hey everyone, I'm Francesco Riccardo di Gioia, and today I'm gonna present this project I worked on with Eugenie Brasier, Emmanuel Pietriga, and Caroline Appert. So, nowadays mobile devices can be used for a lot of different activities, such as browsing the web, reading documents, navigate maps, or watch videos. What's interesting is that such content has become easily accessible to the point that it's sometimes more efficient or just more comfortable to use this device and sitting nearby rather than walk to a desktop workstation to consume this content. But when an activity is limited to consuming content or performing lightweight edits to a document, a mobile device is often sufficient. But there are limitations in terms of both screen size and input capabilities that can still make more advanced activities frustrating. And so by combining handheld device and the hair headset, we built a powerful mobile annotation system. And the two main advantages that we have is that, first of all, because the annotation float in the air around the handheld device, they don't compete with the content of interest. And also we're able to capture elements from the environment from the wearer's perspective. So as we can see in this video, the student here can circle part of the document on the device and then just take a picture of the whiteboard in front of him, which then will become an annotation to actually enrich his class material. To situate our contribution within the related work, we built upon two main areas. The first one is about the system for annotating digital content. Let's look at two examples here. We have spacing that makes room for in-context annotation by dynamically reflowing documents. And we have liquid text that provide a flexible document representation built on multi-touch input. The problem with this system is actually the tension that exists between the content of interest and the annotation, which is something that we solve by having these two display spaces, the handheld device and the hair around the handheld device. And we can do that because we actually combine two devices, the handheld device and the hair headset, which is a combination that has already been explored in other projects, not for annotation, but for other purposes, like Brasier, where they actually propose multiple possible applications with such combination, or Marvis, that explore this combination in the specific context of visualization. And so we wanted to explore the viability of this approach, which consists in combining two devices, a handheld device and an headset for an annotation system. And for that purpose, we built a probe, a crude prototype that enabled us to actually explore the concept. So to assess the viability of the approach, we wanted to actually make it available for a representative sample of the type of content the user consumes on their phone. And that's why we decided to support annotation for text, map, and video. Then we focus on the annotation display space. And here we have two different spaces. The first one is the one used for text and map, which is on the side of the dominant hand in portrait mode. And as you can see there are two rows in which the annotation appear, and the annotation follow the flow of the content, so either the document or the map itself. In the video, we used a different space, which is above the device's top edge, together with an additional timeline, which is connected to the video itself, which provides additional info of where the annotation is compared to the duration of the video itself. And as you can see in these representations, the annotations are actually color-coded in order for the user to connect the content to the annotation. Then we focus on the different types of annotation inputs. So, of course, we can take the usual annotations, like with a digital post-it note on the device itself, or we can insert content from the handheld device. But in addition to that, the novelty in what we propose is that we can also record annotations live from the perspective of the user. So taking advantage of the AR headset, as we saw in the previous video, we're able to capture either a picture or a video of the environment in front of us, and that will become the annotation content. To implement this probe, we had three separate parties: the web client, the web server, and the Unity client. Of course, we ensure consistency between what's on the handheld device and what's in the air, thanks to the bidirectional communication between the web client and the Unity client. And so we ensure this consistency, and also we ensure the alignment between an annotation and its scope on the handheld device, as we can see in this video. And we use the AnnotAR prototype as a probe to gather preliminary empirical data about people's ability to use an interactive system coupling a mobile device and smart glasses for digital content annotation. For this user study, we collected different types of user feedback. So we had the system usability scale questionnaires, and also we followed the Think Aloud protocol that allowed us to also collect verbal feedback. We had two hypotheses to study. So if the users are able to create a diverse range of annotations on the three medias with AnnotAR, and if the users can retrieve an annotation from its scope and vice versa, again on the three medias with AnnotAR. And for this user study, we split these phases between two. The first one is for creating, where we scripted a series of 6 different tasks that participants walk through, involving the AR headset camera feature for each of the 3 content type. And then each task was replicated twice in a row for a total of 12 tasks. The second phase was the one for searching annotation. So the participants had to perform a series of 20 tasks in which they had to identify which annotation was associated with a given scope and vice versa. And for this one, they were used pre-existing annotations, so not the one that they created before. We had a total of 6 participants, and in each phase, the participant followed a script to perform a series of tasks to make them walk through the features of AnnotAR. We're really happy with our results because all tasks were correctly executed, and some participants suggested additional functionality, and in general, the feedback was positive. What's really important is that color coding was immediately recognized, so the participants were able to immediately understand the connection between the content and the annotation itself. And as you can see there, the SUS scores were consistently high. So, feedback from the study suggests that the approach is indeed viable, as participants were able to use the combination of AR headset and handheld device to capture new types of annotation. So now we describe 3 scenarios that illustrate what sort of user experience the combination of a mobile device with smart glasses could enable. And all 3 scenarios have actually been implemented with AnnotAR to demonstrate their technical feasibility. The first one is annotating a text document. And so, as we saw in the first video, the student is able to take annotation from the environment in front of him, and those will become annotations themselves. And so the extended display space means that the annotation can be shown as previews improving this annotation-driven navigation in the document. And the annotation remain easily distinguishable from the main course material, and they do not take any space on the tablet itself, whose display remains entirely dedicated to the main material. And so here the student can circle this specific image and then just start a recording and follow what's happening in front of him. In this case, an experiment executed by the professor. So he can just listen to the explanation, and he doesn't have to care about taking written notes in the case. And when he's done, he can just stop the recording, and that will become part of the annotation themselves. And so the second scenario is annotating a map document. So a person can just focus on the map in the device and then either circling or add a pin to a specific point and add an annotation related to it. So this saves screen space on the small handheld device, and it's interesting because this time displays a very dense and complex widget, which is the map itself. And also offloading into the air also lets the user quickly access and review all his annotations, since these can be represented as preview thumbnails. And so in the video we have the user that is drawing a shape and then can just take a picture of the work site in front of him, and that becomes an annotation on the side of the device. And lastly, we have annotating a video document, which is slightly different from the other two scenarios, and where the user can still circle a specific part of the frame of the video and then connect an annotation to that part of the video. And displaying the annotation in the air does not occlude the video itself, and it also makes it possible to arrange them temporarily along a timeline that is also floating in the air, which better shows the distribution and the scope, in this case the time interval of annotations across the video. So as we can see here, the user just writes something on the digital post-it note, which becomes an annotation, and you can then consume all the different annotations, which are color-coded, connected to the timeline and to the color on the device itself, in this case the orange one. And so this was the system with the 3 different scenarios, and this concludes my talk. Thank you very much, and please let me know if you have any questions.